Hi, this is Alex from devstories.eu. Pulumi, Infrastructure as Code, Episode 5 of 10. Copy-pasting your infrastructure code to create a staging environment is a recipe for drift and disaster. You end up maintaining multiple folders of nearly identical files, and eventually somebody forgets to update production. The solution is treating your environments as isolated instances of a single codebase using stacks. Before going further, let us clear up a common point of confusion. A project in Pulumi is simply a directory containing your source code. It is just the instructions. A stack is an active deployment instance of that code. You write the project once and you deploy it multiple times as different stacks. Stacks let you manage different environments like development, staging, and production without duplicating any code. When you run a Pulumi update, it applies the code in your project to whichever stack is currently active. Each stack maintains its own isolated state file, tracking only the resources created for that specific environment. Managing these environments happens directly in your terminal. You create a new environment by running the stack initialize command, giving it a name like dev or prod. Pulumi registers this new instance and creates a fresh state for it. To switch context, you use the stack select command. The Pulumi CLI remembers which stack is active. If you select the dev stack and run an update, Pulumi only looks at the development state. It provisions or modifies the development infrastructure, leaving your staging and production environments completely untouched. That covers deploying isolated environments, but what happens when these environments need to communicate? Sometimes one stack relies on information generated by another. You might have one project managing core infrastructure and a totally separate project handling application code. Let us say you have an infrastructure project that provisions a Kubernetes cluster. You deploy this as a stack called base infra prod. During deployment, the cluster generates a dynamic connection string. Now you have a second project for a microservice that needs to deploy into that exact cluster. You don't want to hard-code the connection string, and you don't want to merge both projects into one massive, slow-moving state file. This is where it gets interesting. You can securely bridge these deployments using a stack reference. A stack reference allows one stack to read the exported outputs of another stack. To set this up, your Kubernetes cluster program must explicitly export the connection string at the end of its run. An export is just a variable that Pulumi saves into the stock state, specifically so it can be read from the outside. Then, over in your microservice program, you create a stock reference object. You pass it the name of the infrastructure stock you want to read from. Next, you call a getOutput method on that reference, asking for the connection string by its exported name. Your microservice can now use that value to configure its deployment. The microservice stack cannot modify the cluster stack. It can only read the specific values the cluster stack chose to export. This enforces a clean boundary. You can update and scale your core network infrastructure entirely independently of your application workloads, while safely passing the necessary connection details across the gap. By decoupling your code from the environment instance, you guarantee that every tier of your system goes through the exact same logic, removing the hidden risks of manual duplication. That's all for this one. Thanks for listening and keep building.